thanks, Kyle, for the invitation and for the introduction. Yeah, this title doesn't mean anything serious, actually. I'm the after lunch talk, so we need to take it easy. I'm presenting, but it's showing the work of many different people. So of course, I want to thank all of them. So what do the dog bark basically? We heard in some of the presentation this morning already that, okay, maybe it's time to go and move forward and, dioxin issue might be solved or not, So a lot of people argue in both directions. So, and I'm going to just give you my point of view on this thing. But those are a few of the questions that people might ask you if you say, oh, I'm doing dioxin analysis, and they might say, oh, dioxin, that's the old thing of the Seveso incident. Is it still of concern today? So that's, why I decided to put those slides together. And maybe, and we heard again about that earlier today, but we're just looking to dioxin and PCBs or dioxin-like PCB. It's much more than that to look at, of course, and not only on the POPs area. So this is just, if you go to Scopus and you just, I was going to say Googleize, but you're not Googleize in Scopus, you're going to Scopulize, I don't know how to say that. Anyway, you type, that's how to say it, you type dioxin in Scopus, and this is the evolution of the publication rate of all journals of original papers and reviews for dioxin for the last 20, 25 years. This is starting back in 1975, 76, the Seveso incident. But it all started much earlier. We heard from Peter this morning that even in the 18-something, people were already kind of touching the dioxin issue. Then we had the is it reading fingerprints? Or? Oh, here we go. 68, it was the Yusho incident in Japan. That's the first big food contamination was for PCBs, basically in rice oil. Then it was, of course, we heard about that earlier, the Agent Orange use of Agent Orange in Vietnam, which was quite heavily contaminated with dioxins. Then it was, of course, the Seveso incident. This is where I start this x-axis. And then it was a couple of, the Hudson River, the Love Canal, the Escambia scare, the Mount Dioxin, and those not that much publicized event mainly in the US, the Yucheng incident in Taiwan, the same type of incident than the Yusho incident 10 years later. We heard again earlier today that we don't really learn much from the past. I mean, things are cycling back and back and back. So, the mad cow disease is a bit like this too. Some other incidents. And then we had, this is what I'm proud of because I'm from Belgium, we had this dioxin crisis in Belgium back in 1999. And this is what I would use to sort of define a pre-Belgium crisis and a post-Belgium crisis time. And you can really see a clear cut in the number of publications that are released or that were released before the crisis and after the crisis. It really, it was a boost again in the interest, and we are now close to 1,000 papers per year just for dioxin. So that's definitely something people are still interested in, and they still work on that, and they still publish paper. And today we are, of course, there, and you can see this is, I did that, those numbers are from this morning, actually. So, but I wanted to do that, fresh numbers. So, it's rising. So, if you just focus more seriously in both cleanup, food or feed aspects, so still doing in Scopus, doing dioxin research, but then you look, for example, on the food, and again, the pre-dioxin crisis, Belgium dioxin crisis time, or the post-dioxin crisis time, I mean, a lot of paper, a lot of attention has been given, especially to food and feed, both on the cleanup and on, of course, the level side of the research. So we've seen that earlier. This is not an exhaustive list, but because of all the regulation we already heard about today, a lot of small crises, I'm going to say, or dioxin even have been spot, and that probably reduced quite significantly the exposure of the population. So we can say a lot about the dioxin analysis. We can ask ourselves if it still makes sense to do those analyses. But I think even if the dogs are barking, I mean, the Caravan still goes on because a lot of research, and this is, I mean, you are there. So I think I'm right in what I'm saying. So that's just to give you, to set up the scene, basically, of those analyses. So we could say that the Caravan really departed from the dioxin crisis time. I mean, before 1999, there was some regulation, especially in Germany, about dioxin levels, but there was no harmonization of those levels. So if you look to the German legislation or the French legislation before the crisis, it was sometimes quite different. So that really had the advantage, if I can say so, to start a lot of things. We had the Consume program starting in Belgium just after the crisis to start to continuously monitor the dioxin levels in food and feed. And also at the EU level, we really had and this is a capital word, the harmonization of the maximum residue levels. So on the EU level, everybody was agreeing on the same type of MRLs, and that allows to basically start a continuous monitoring program. So every day, samples are analyzed for dioxins, and it really started early 2000. And of course, the EU had to develop a strategy. Alex told us about the strategy earlier today, so you all know about that now. And the few keywords there are the use of the upper, medium, or lower bound levels. We heard again about that earlier today. And for different reasons, the approach was a screening versus or with a confirmatory approach, mainly because we needed high capacities to have a rapid alert system inside the EU. So we needed to have the capacity to be able to analyze a lot of samples in a short amount of time. And remember, this is in early 2000, because I'm going to go a bit over that date. And the major reason why the strategy was based on first screening, and then if you do have a suspected positive sample, go for confirmatory, was because this state-of-the-art GC C13 label isotope dilution high resolution MS was kind of expensive, slow, and you were not able to. It was very difficult to process, let's say, 100 samples a week with this GC high resolution mass spec. So the screening was interesting because either using more simple GCMS tools or biological tools like response binding assays, like the Calyx, for example. That's the widely used assay. At that time, again, back in 2000, they were able to shoot much more samples, which was also cheaper, so that's perfectly good strategy to use that for screening. And then the positive sample, you shoot them, you have the congener profile, and because you have the congener profile, you can look back and try to trace the source of the contamination, which is very important as well. So that's to show why the strategy was used. I'm going to have to. It works. So it's a bit probably too small, but this is just a really simplified scheme of the current EU strategy, where you do have the samples, you do screening, and then you can have, let's say, suspected positive or negative samples. Then based on a cutoff value, I'm not going to go in detail, the sample can be compliant, or if it's suspected positive compared to the maximum residue level, you need to confirm it by the so-called confirmatory method, which is GC high resolution sector instrument, although triple quad are coming, but you heard about that earlier. So if you then have to confirm, you move to the next step where either it's compliant, so it's a negative sample, if I can say so, or you go on the other side, and if your GC high resolution MSA, it's a positive sample, you duplicate it, you do the average calculation or the mean calculation, you include the measurement uncertainty, and then you decide if it's compliant or not. So it's very simplified, but that's the global idea of the screening. So you're just sorting out the samples to reduce the cost and to speed up the process. And based on that, the European Food Safety Agency has been releasing a report. I think there is a new report coming soon, but I haven't been able to find it. But they've been reporting on levels of dioxin, furanes, dioxin-like PCBs, and PCBs. So that's a very interesting piece of report where they're showing a lot of data, close to 20,000 samples for the non-dioxin-like PCBs, close to 15,000 results for the dioxin and dioxin-like PCBs. So it gives you a good overview of the EU levels for the level of contamination, or the background level, we should say, for dioxin and PCBs. And I'm not going to go, of course, in all the conclusion, but this is some of the major points that they reported, where eels, but we know that, and fish livers are the heavily contaminated sample in terms of food. So this is really where the attention should be focused. This is the intake that can be calculated compared to the food habits of the EU population. So this is, those numbers are quite large. It's a very large range for based on the TQ for per kilogram body weight per day. So it's really giving you an estimated value. And we all know that the fish group, the meat, and the dairy product are the major contributor to the human intake. But I mean, that's nothing new there. Has been published like 20, 25 years ago already. And the exposure is decreasing. We heard again that earlier today, so we are on the good trend. But still, if you look to the proportion of the population that possibly exceed the tolerable weekly intake, I mean, that can range, from 1 to, let's say, 50% of the population based on different parameters. So, yeah, we still have to look at those compounds because there is something to do there. And this is just at the end of this report. They say full compliance with legislative requirements for analysis and reporting would facilitate future Europe-wide risk assessment. So they need robust data. That's the message there. And one, later on in the document, they say we should focus on major food contributor for which no robust methods are in place. So that's kind of surprising to see that it was in 2012 that for some specific matrices, for example, no robust method was in place. Although we thought, we've been analyzing dioxin for a long time, but still some very specific matrices. And we heard from Alex earlier that, focus on specific extraction procedure should be dedicated and those things. So we have to work in that direction. We still have to do some research. And this is, I'm back to, this is the organogen compound series. So those are the dioxin meeting abstract. And just for your information, you can download all of those abstracts free of charge from the dioxin20xx.org website. So just to let you know, it's a gold mine. A lot of information is available there. But then at the time, early 2000, when the screening confirmatory approach was set up by the EU, it was some working groups starting to provide guidelines. Okay, this is how you should try to make your measurement. And as we heard before, this is based on performances. This is not a recipe that is given to you, okay, please apply the recipe and that's going to be okay. It's just guidelines. For example, about the validation information, you have to participate to proficiency testing. You have to use the upper bound and the lower bound. The difference has to be, below a certain value, etc., etc. So those are the major guidelines. But if any of the method that you would propose can fulfill those requirements, then you have a chance to be able to work in agreement with the EU legislation. So I believe this was really the starting point of something very important, which is this performance-based method, which you can define. It's difficult to read, but it just tells you what you have to do, but it doesn't tell you how you have to do. It's guideline. Okay, they tell you have to use sector instrument, for example. That's a fact. But then, next to that, you can really do the extraction you want if you can show that you have good recoveries, etc., etc. It was also these documents, and Wim Track is there, so if you have any comment on this, go to him. But this is a very important piece of documentation, which, again, is quite new. The 16 to 15 is, again, giving a lot of information, a lot of guidelines, how you should proceed to do a good, let's say, dioxin or dioxin-like PCB analysis. And it's, again, the same philosophy of based on performances instead of a practical recipe. And this is a snapshot of one part of this document where, for example, you've got the extraction, the cleanup and fractionation there, and then you have the analysis. And you can see here that you can go either for pressurized fluid extraction or ACE or PLE, call it as you want, or you can go for Soxhlet extraction. You have the choice. So this piece of documentation doesn't tell you, forget about Soxhlet, you have to do PLE. No, you can still do Soxhlet if you want. You just have to fulfill the requirement. And then you have on the cleanup, you can really go for manual cleanup based on both extraction technique, or you can go for automated cleanup. We saw a couple of systems earlier today, so it's up to you. I mean, you have the in-house manual procedure, just do it, use it, and that would be perfect. And then, of course, at least for confirmatory, the analysis has to be done by GC, high-resolution MS, and now triple quad. I mean, very soon triple quad will also be accepted. So if you look to each of those steps, so if you look first for the extraction based on this very nice paper from Richter back in 1996, where he was publishing the ACE principle, where you just have a stainless steel cell, you just put your sample, a solid sample most of the time, you put your sample in the cell, you just fill up the cell with the organic solvent, you pressurize, you heat, so you are able to use the liquid organic solvent at a temperature above the boiling point. So you keep a fluid, although you are at temperature higher than the boiling point, so the extraction efficiency is increasing. So that's a very simple principle if you look to the phase diagram, but it's some sort of intermediate between supercritical fluid extraction and solvent extraction, if you want. That's very nice, and that's very easy to use, and it's very efficient. But we still need some harmonization for sure in the future. And this is now available commercially with, from different vendors. The latest generation can allow you, after extraction, you just flush your compound, so the solvent is flushed. You can, start the evaporation of the solvent while you are still extracting. So if you do a few cycles of extraction, you can save maybe 1 hour or something by evaporating your solvent, although let's say the cycle number 3 is still running on. So in terms of speeding up the process, it's important. Just a picture of this type of system where you can have small volume or larger volume of extraction, depending on the matrix. If you have to extract feed or food, it's not the same thing. So that's important to be able to show that. And this is the evaporator, which is directly connected to the extractor. That's the first step. So the second step, either you go for manual or you go for automated, based on this document. And I think we saw probably one of those two pictures, at least a scheme of this picture in Peter's talk, where Smith and Stanning have been reporting this, and probably 80% of the dioxin lab in the world are based. Their procedure are based on this Smith and Stanning paper, which is back in 1984. You see Peter, who is Peter? I'm separating the date and the page number. It's easier. And Dave Stanning was actually receiving the Life Achievement Award at the Dioxin 2011 meeting for this early publication. We saw definitely this picture earlier, and then I know that you've been there, so I just add this picture as well, just to give you what you deserve. But just more seriously, if you look to this, it looks, for me, it looks fun. I mean, it looks like a strange machine there, and then it was a few generation of system until, this is one of the last generation of this automated system. So it has been a long time, and a lot of improvement of this type of instrumentation. And I think, today we really have automated system which perform very well and can easily be incorporated in accreditation exercises, for example. And this is the improved Smith and Stanning scheme. But when I say improve, it's just because there is some color, because the scheme is exactly the same. The exact same procedure is still used. Multi-layer silica column, basic alumina, carbon columns. This is the same adsorbent that have been used for the last 30 or 40 years. And again, at the end, you can hook up a evaporator to speed up the concentration, because one of the major drawbacks, of course, is still the volume of solvent that you're using. You can optimize, you can reduce the size of the column, etc., but still we're talking about milliliters of solvent. I would love to talk about microliter of solvent, but when you have to process, let's say, 200 grams of meat, it's difficult to extract 200 grams of meat with 50 microliter of solvent. So we cannot do that yet. This is why we need better instrumentation. So those evaporators can also just give you the direct connection with the GC vial. So it looks, okay, that's a gadget, that's very stupid, but it's not. I mean, once your concentration is done, if you can just unscrew this and put that on your autosampler, the major thing is not because you are a lazy person, it's just that because your vial and your evaporation, you're not open to the external air. So in terms of blank management, it's very interesting. It's one step less to take a Pasteur pipette and transfer your extract, basically. So that's where the added value is. So then you just put that on the autosampler. If it's, let's say, 100 or 150 microliter, there are some large volume injection available for the GC aspect. So you can just, take like a few, let's say 20, 25 microliter of those 120 microliter, shoot that on your mass spec, and you can integrate your peaks if you are lucky enough. And you can also integrate the solution. That's something you can do, but you don't have to do. So again, back to this scheme, if you just want to put all those steps together, so let's say the PFE or the PLE with the automated cleanup system, that's an option you have. You need to keep in mind that most of the legislation is based on a fat basis, so at some point you need to weight the fat. So if you integrate everything, you need to do a fat determination on the side, which will cost you money and take you time. So just keep that in mind. And then it's very easy to do the coupling because you take the two systems and you connect them with a tube. So that's it. But again, more seriously, it's not always trivial because the extraction solvent from the extraction step is not the same that the cleanup solvent. So you have to exchange the solvent, and this can be a very delicate step, as was shown by some of the colleagues earlier. This is the last generation of those coupled systems for solid. So this is the solid version. And this is for liquids where you have solid phase extraction or PLE. So you have the choice depending if you're going to process breast milk or if you're going to do, let's say, soil or feed or food. You have different options. And this is more or less what any lab can achieve. And I'm saying about any lab because it's medium-sized lab, where, again, sorry, it's a little bit small, but from the sample reception, homogenization, you can have a drying step sometime because if you receive the feed, you have to dry the feed overnight, for example, so it takes time. That's something we could definitely speed up. Then the PLE step, 1.5 hours, the solvent reduction, number one, because let's say at the end of the PLE, you have 100 milliliter of solvent that you cannot take the 100 milliliter and go for the cleanup. You need to concentrate that, so it takes time, even if you use vacuum evaporator. Cleanup and fractionation, let's say 2 hours for a cycle for 10 samples. Another solvent reduction, then the GCA high resolution, or the GCMS, I should say, analysis, and then the QA/QC check, and then you can send the report to the client. And then this, depending if you have or not to use the overnight drying, can be done in less than 24 hours. So that's very, very different from what was the situation back in early 2000 after the dioxin crisis. So at the time where the strategy was set up. So maybe we should rethink of the strategy. So then, in this the same ID, this is a document, and I don't know, Rainer, if there is a more recent document than this one, but I don't think so. But those are, I should have been rounding the numbers, but this is just giving you the, let's say, the capacity of all the EU official laboratories and national reference laboratories in terms of dioxin and dioxin-like PCB analysis. Again, this is from 2009, so it might have changed a little bit, but you've got the screening and the confirmatory. And when you look to the number, which for me is kind of surprising, is that if you look for the screening, the average EU capacity in terms of week, if you combine food and feed, this is, let's say, 1,200 and 800. So let's say 2,000 samples can be screened every week with all the EU labs, which are official or national reference labs. And the confirmatory capacity is, let's say 7,500. So as of today, we have more capacity to confirm than we have to screen, which is a bit strange to me. But so that's maybe why we should rethink of it, because this is what was true in 2000, but now that the MS has been changing, the automation system, the automated system have been made available, the price have been decreasing, so maybe this is not true anymore, and we should think of something else. And the first element of reflection could be, okay, this is in terms of cost per analysis, this is the situation early in 2000, so right after the dioxin crisis, when it was decided to go for screening and confirmatory. One dioxin analysis using GC high resolution sector instrument was, let's say, above, let's say, between 800 and 1,000 euro. In those conditions, I fully understand that we should find something else because it's very expensive. You cannot do screening at that price. And the bioassay, I would say, or the screening assays were like less than half the price of this. So that was a lot logical to do that. Now in 2010, 2012, maybe, the prices have been decreasing. So for the price, the price of the confirmatory method is not even half of what it used to be 10 years before. And the speed of analysis have been changing a lot. I just told you, in 24 hours of time, you can really get sample to be shooted, analyzed, and reported. And remember, the big difference is that if you do GC high resolution MS or GC triple quad, you do have a congener profile for 20 plus compounds, which, as we heard from Alex, it's very important to make some sort of database of the type of contamination, even to try to help tracing back the event. So this piece of information is very important. And of course, the price of the screening assay has been decreasing as well, which is all good news, because the combined price of the confirmatory and the screening is cheaper than just the confirmatory 10 years ago or 15 years ago. So that's very good news. But then the situation has not been changed. So we're just saving money in terms of government calculation, if I can say so. So if you try to go for the next step, what's going to be the situation in 2020? And I'm just guessing, I have no concrete numbers to, it's a hypothesis, that's just that. And if, I'm going to be dreaming here, right? Okay, I'm going to be wild. So if you just think of some sort of legislative target analysis using the mass spec, and I call that the real use of Calyx. Some Calyx people don't like when I say that, but please forgive me. And we do like some real Calyx screening. What I mean by real Calyx screening is that instead of spending a lot of time polishing the extract, just to keep the dioxin and the PCB and be able to use the calyx in the legislative area, we could step back a little bit. We still have to process and clean up the sample, because if you feed the cell lines with shit, they will just die and you won't measure anything. So you still have to process the sample through a very drastic cleanup, but not only for dioxin. You can keep the other guys, the other possible AH receptor molecule that can bind to the AH receptor. So if you look, the price could keep decreasing there. And in that case, you could start to think, okay, we don't do confirmatory screening. We do only confirmatory for the legislation. So we want to check the dioxin level, you only do GC mass spec. And because the triple quads are coming, maybe it's even going in the direction there. And then you can also say, but every sample that you are checking with the old confirmatory method, you also check all of them with the calyx, with a more general approach than just for the dioxin. So that's, that would be, those samples would be checked with the calyx. So the total price would be close to the price of only the screening today. Okay, it's plus minus 10, 15%, but I'm just guessing those prices. So I can say anything I want, actually, because it's just science fiction. But it could be the truth in next few years. And then this would be the new approach. You get a sample. You get all the sample for which you want to measure the dioxin level to be shoot on the GC mass spec, triple quad or sector instrument. Then you've got the maximum residue levels. You can check if it's compliant or not. If it's suspected non-compliant, you duplicate, you do the average, you include the measurement uncertainty, and you say if it's compliant or not. And maybe the not compliant can be reinjected in another place there with, for example, GC high resolution TOF MS. I'm sorry, I cannot give any talk without talking about GC a little bit. But GC times GC with high resolution TOF could also say, okay, you've been measuring high level of dioxin and furans. Maybe they are not the only guys in this extract. Okay, so that's why it would make a lot of sense to re-inject part of those samples in the GC high resolution TOF. And remember, all the samples that have been screened for the maximum residue level of the target compounds, all have been screened with a real toxicity calyx, where you can have very low response or high response. And I would say, let's just focus on the high response. Again, you do more exhaustive searching, non-target, just screening, but on the mass spec side, you can take 2 to 10%, we like to do that, so let's do that. We like to take 2 to 10% of the low response real toxicity calyx sample, shoot them on the GCR resolution TOF, and then we try to identify the compounds. Is there more compounds that we were expecting? Let's look at the antagonist or those compounds that might be responsible of the high response. I have no clue what is there, but that probably makes sense to look at it. So just look at this number and this number. So if I take the number of samples that have been analyzed at the EU with confirmatory screening for an average year in the last 5 years, I think, this is in kilo euros. So this is 14 millions for the number of samples that have been analyzed with both confirmatory and screening. And if you change the approach, if you follow what is proposed, the price will be 16 million euro. So compare 14 million to 16 million. But of course, the scientific value of this one is much higher than this one. So maybe we can, cut the cost a little bit and go to the equal price to try to convince the politics. But I think that's really the time to think of it. So I'm going to finish on this. I'm just going to focus on the last sentence, taking full advantage of what separation science can offer us. I mean, mass spec has been evolving really tremendously for the last few years. And I think, we heard about the Orbitrap, for example, but it's a lot of different options that are now available, and we should make use of it. We are still using a system, I believe, that was very nice in 20,000, but 2015, we should move up to something else. So if you are interested in this view, again, this is just my personal view, and you can think it's just shit, but I just wanted to share that with you. In the next May issue of the Analytical Scientist, I just wrote a little thing on that. So just if you want to have more detail, just go there. And my colleagues Lourdes and Juan also wrote a, in my view, little article there to promote Dioxin 2014. But Begona is there, so she will promote the Dioxin meeting herself. But just put that in your agenda just to be sure to attend. So from there, I thank you for attention.